Hi everyone, my name is Neha and this is the 13th lecture on Introduction to Microcontrollers. In this lecture, I'm going to show you the program on rotating LED with consistency. So let's get started. In the last lecture, we covered a program on rotating LED, but that program had one shortcoming. And if you would have run the program, which I showed you in the previous lecture, then you already knows what was the shortcoming. But I have put up a quick video here, which will let you know here that what was the problem with that previous program. So let's start here. So you can see the LEDs are turning on towards the left. That's what we want. But then if you notice, after this, there is a delay. There is a delay and then this LED will be turned on. So this delay, the delay which you see here is pretty long, and we do not want to have that long delay. And we have to change the code in such a way that there is no delay and all these LEDs, they turn on in sequence and in a continuous loop. Okay, so let's see what change we need to do into our previous program, which will remove that delay. All right. So blinking LED rotate consistent with consistency. So what do we actually need? So you know this, you are familiar with this port A resistor, RA0, RA1, RA2 until RA7. And you know that RA4, RA5, RA6 and RA7 are the one which are there on the development board. These are represented by the LEDs. So let me quickly go back here. So you see here, this is RA4, RA5, RA6, RA7. All right. So these are the four LEDs we have, and we want these LEDs to turn on towards left one by one. All right. And if it turns towards left, if these LEDs turn on towards left, then this is the sequence of the 8-bit number into this port A resistor. So initially this will be on. I think I'll show you with these LED picture here. So they shows RA4, RA5, RA6 and RA7. These are the four LEDs, and at RA4, RA4 will be turned on if you provide this 8-bit number. So 001, and then this will be all 0. Because this position is your RA4, and then if you turn on RA5, then this will be your 8-bit code, and RA6 this will be your 8-bit code, and RA7 if you want to turn on, then this will be your code which will go into the 8-bit register to turn this on. So this is the basics which we already know, but we did a quick revision. Now we are going to see what instruction set we need or we need to add into our previous program, and which will help in making these LEDs turn on in consistency without a long delay, which we saw in the last slide. So the instruction set, the new instruction set which we'll be using for the consistent LED rotate code will be this. This is the new addition: bit test F, skip if clear. I have already covered this instruction set in one of the instruction set summary lecture, and this is I'm going to quickly cover this again. So this is the syntax: btfsc f comma b, where f is your file register. You will put the name of the file register here, and b is basically test the bit. So you can quickly read here: if bit b is in register f is 1, the next instruction is executed. If bit b in register f is 0, the next instruction is discarded, and an op is executed instead, making this a 2-cycle instruction. So at this position B, you can define any bit. You can see this bit range is from 0 to 7. So any bit where you want to work, you can put that bit name. and this F is your file register, and you can see that this is the range of file register. So let's quickly see the program. So this is the main starting of the program, and this program is same as previous program. Bank cell port A, you selected the port A using the bank cell instruction, and then clearing the port A, so all the bits in the port A register will be cleared. Bank cell trace A and clear F trace A, so selected the trace A and then clearing F. Trace A means setting all the bits in the port A as output. Now here is the change. Starting with this INIT, this is my label, and these are my two instructions. These two instructions are again the same, which you see here. And then we have this main program. So this int label under this, you know that this says move LW, which means this is going to move this literal number into the working register, making RA4 as high. RA4 is your LED, and move W to F. So moving this literal number, which was already moved into the working register, moving it to the file register named by this LED. So LED is my file register name. So in this register, this literal number will be moved. And then let's see the code. So this is the main code here, and you can see move F LED comma 0 and move WF port A. So these port A and then call delay. So these are the same instruction set from the previous lecture. The only difference is these two instructions have been added. So this is new code added to the previous code. The rest of the code is actually same. So adding these two codes will make your rotating LED program very consistent. Now let's see how it works. So we understood till here that into the LED file register this literal number has gone, and then move F using this instruction. What's going to happen? Whatever you have in the LED, that will be stored into the working register, comma 0, because this 0 indicates storing the value in the file register into the working register, and moving the content in the working register into the file register. File register is my port 8, so moving the 8-bit number into a port A and then calling a delay. So until this point your LED RA4 is turned on, and then a delay is there, and then it's supposed to be turned off. So between that we have these two instructions, and after the delay is called, it will come to this instruction, which is VTFSC LED comma 7. So what does it mean? It means that it is going to do the bit test and bit test F, skip if, clear. So it is going to do the bit test at 7th bit. Okay, so I have shown here, if you see on this right hand side, I have shown here 8-bit number, this which correspond to your LEDs. Okay, so you know that this is starting from RA0 to RA7. RA4 is right now turned on. Okay, and this is the RA7, which means the 7th bit. This is the 7th bit. So using this instruction set, the program is going to test this bit, okay, every time. So initially the first is initially, so until here we had RA4 is turned on. So it's going to now, coming after delay, it is going to test if the 7th bit is 0 or not. So if the 7th bit is clear, then what it's going to do, it's going to skip the step. Okay, that's what this instruction means, bit test F, skip if clear. So it is clear right now, so it is going to skip the next step and will go to this step. Okay, so at this point RA7 is 0, so that's why it has skipped, and in the next step what's going to happen, it's going to rotate the LED to the left, which means the next LED will be turned on. And again at this point, and then this says go to main, so go to main is this one. and then again do the same, follow the same instruction, and then check at this instruction set, bit test F, skip if clear. So it's going to do the test again here, and it is still clear, so it's going to skip this instruction set and directly jump to into this. So after this instruction set, it will directly jump to this rotate left F LED, comma 1. Okay, so it is going to rotate, and then again it is going to do the test, and it will see it is still clear, and then it will do that. And then in the fourth step, when RA7 is turned on, when it reaches here, at this point RA7 is turned on, when it reaches here, it says bit test F, skip if clear, and it sees this bit is not clear. So if it is not clear, then go to init. So it will go to this step, go to init, which means it will go to this step. Okay, so you see that with the help of this instruction set BTFSC, we are testing the 7th bit, and if you do that, then it is going to make your program very consistent. So add these two lines into your previous code and see if there is any difference.